Welcome to U6L1 2D applications. So in this lesson, we're going to talk about how to apply area, perimeter, and circumference to solve different problems involving two-dimensional shapes such as circles, squares, and rectangles. So before we start this lesson, I would recommend just to remind yourself of what the formulas are that you're going to need to use. Area of a rectangle or a square is length times width. Area of a circle is pi r squared. The circumference of a circle is 2 pi r. And then the perimeter would just be adding all sides of the figure, whatever figure it happens to be. All right, so here's some steps in order to help you have some focus when you're working on these problems. First thing, determine what kind of value must be used. Sometimes it'll tell you directly. Sometimes you have to read what it's asking and determine from there. But that would be area, perimeter, circumference, something like that. Sometimes you have to solve for individual values and then add them together or subtract them or something like that. And so you solve for your individual values when necessary, and then you can complete your final calculations. If there's units in the problem, make sure you have the correct units in your answer, such as like inches, meters, etc. And then remember, when you have area, right, all those units will always be squared. Okay, so the first problem here, it says example 1. A 10, this means inch. Okay, this right here, this means inch. A 10-inch by 13-inch wooden frame can hold an 8-inch by 11-inch certificate. What is the area of the wooden portion of the frame? And then it gives a picture so we can kind of figure out what the scenario was really talking about, right? So we have a wooden frame, and so the wooden frame is going to be this part on the outside, right? All of this. So that's our wooden frame. It says it holds a certificate, so this is where the certificate would be on the inside, okay? And it wants the area of just the wooden portion. So basically, it wants the area of a rectangle, but not the whole thing. It doesn't want this whole thing, right? It wants the area of that rectangle, right? But without this part where the certificate goes. So what we're going to have to do is find the area of the whole thing and subtract out this part in the middle where the certificate goes. Okay, so what we're going to have to do is find the area of the 10 by 13 and subtract from it the area of the certificate, which is the 8 by 11. Okay, so we're going to have to do some subtraction in order to find the area of just the shaded part, which is the wooden part of that frame. So the area of any rectangle is length times width. So for the area of 10 by 13, you're going to do 10 times 13 minus, and then the area of the 8 by 11 is 8 times 11. So 130 minus 8 times 11, which is 88. And then you just subtract those. Okay, you just subtract those. So 130 minus 88, and you get 42. Okay, so 42 is the area of the frame. And remember, so these little marks mean inches. So it's 42 inches. And since it's area, it's going to be squared. So 42 inches squared is the area of that wooden portion of the frame. All right, next one. So example 2. Let's take a look. Find the perimeter of the figure below. I forgot to type this when I wrote this in here, but you want to assume that all angles are right angles. Okay, so assume every single angle, like this angle is a right angle, angle is a right angle, right? All the angles are right angles. All right, assume those are all right angles. All right, that being assumed, we are going to figure out what the perimeter is. Well, the perimeter is easy to find, right? You just add all the sides. But hopefully you can see that some of the sides aren't labeled. So we're going to have to basically look at the figure itself and look at opposite lengths and figure out what the missing sides are. So for example, we have on the top 15 and 24, those are both labeled going across, but we are missing this right here, this height here. Okay, but we can figure out what that is. So if we look across from it over here, that's 15. And then if we go this way, we see a height of 8. So basically this whole height, it has to be 15 so that matches this other side, right? And so basically this whole height is 15 meters. We already have 8 meters. So to find what's missing, you're just going to do 15 minus 8. And that's going to be 7 meters, okay? So I'll write that next to it. So sometimes you just have to go across and do a little bit of subtraction or addition. Okay. All right, let's keep looking. So what else are we missing? Go around. We have that. We are missing this one right here. So we're missing this height right here. That one's very easy to find because it's exactly the same as the one across from it, which is 19. Okay, so this one's going to be 19 meters, just like this one. What else are we missing? So we have this one, we're missing this one going sideways. Okay, now it isn't 24 because as you can see, they don't line up perfectly, right? It isn't 24, but what we can do is we can figure out what this distance is all the way across the figure from left to right, which is going to be 15 plus 24. Okay, it's going to be these two values added together. And that's going to be 39. And then it's going to have to be the same on the bottom. Okay, so on the bottom, your 6 plus your 13 plus the one we're missing has to also equal 39. So that means that if I call that x for now, okay, 6 plus 13 plus x has to be 39. So if we subtract the 6 and the 13, 39 minus 6 minus 13, we're left with 20. Okay, so if we subtract these both from the 39, then we end up with 20. So we know that this value is 20 meters. Okay, actually, let me write it like this. 20 meters. Okay, now let's make sure we have all the values. We have the top, we have this side, 24, 8, 20, 19, 13, 19, 6, 15. Now all we do is add them all together. So we add all values. Add all lengths for perimeter. So our perimeter should be 15 plus 7 plus 24 plus 8 plus 20 plus 19 plus 13 plus 19 plus 6 plus 15 again. So starting here, going all the way around our shape, we have to add those all together. I'm just using a calculator to make it faster. Okay, so you add all those values up, and you should get 146. So our perimeter is 146, and it's meters. It's not squared because we're just adding all those lengths up. We're not multiplying anything, okay? All right, perfect. Example 3. Example 3 says, a rectangle with length 24 and width 18 is inscribed in a circle. What is the circumference of the circle in terms of pi? So first question, what is it asking you to find, right? What is the circumference of the circle? So the circumference of any circle is 2 pi r. So what you would need in order to use the formula for circumference is radius. So we need to find the radius. If we know the radius of the circle, we can figure it out. Right now, all we know is something about a rectangle, though. Okay, so let's figure out that scenario. So a rectangle with a length of 24 and a width of 18 is inscribed in a circle. This means that it is inside, okay, the circle. Okay, and what it also means is that all vertices, which those are the corners of the rectangle, all vertices, I'll say it this way, touch the circle. So they don't cross over the circle. They're not inside the circle. They actually touch the circle. So I'll show you what that would look like. So we'd have a circle here, okay? And we'd have a rectangle. So I'm going to do my best to draw a rectangle in there. And all of the vertices, they just touch the circle. They don't go across it. They're not inside of it. They are just touching that circle. Okay, now what do we know about rectangles? Well, hopefully you remember that rectangles have opposite sides that are the same, and they have all of these right angles. Okay, rectangles and squares are the only shapes that have right angles inside like that. And the only time you can do what we're about to do is when it is a rectangle or a square. Okay, so let's add our 18 and our 24. So our 18 and our 24. Okay. And now remember, our goal is to find the radius so we can plug it into circumference, right? This is our goal. Right now, we don't have the radius, but I want to show you something. So whenever you have a rectangle or a square, this only works when it's a shape that has right angles inside, rectangles and squares. If you draw the diagonal from one vertex across to the other, that is always going to be the diameter of the circle. It's always going to go through the center of the circle, and that is always going to be the diameter. Okay, that's only if a rectangle or a square is inscribed. Okay, that won't work if you're inscribing something else, some other type of shape. Okay, a triangle, some other kind of four-sided shape, things like that. Okay, but if it's a rectangle or square, it will work. Now, there's more to why that works. Right now, I just need you to know that that is always going to be true, that is going to be the diameter. So I'm going to put D for diameter right there. Now, we're going to bring in something that we have used a long time ago, okay? Because in order to find the radius, we need to find that diameter, right? Because if this whole thing is diameter, then the radius is halfway. And so if we can find the diameter, all we have to do is divide it by 2, plug it into that easy formula, and we're done, right? So this is going to be the hardest part. We're going to use something that we used a long time ago. Whenever you have a right triangle, you can use trig. We did that recently. But that only works when you're talking about angles. In this case, we're not talking about angles. We're only talking about the sides. So we're going to use Pythagorean theorem. Okay? So we're going to take this triangle over here, and we're going to look at just that one triangle separately. It's got a side of 18, 24, and then D for diameter. And we're going to use Pythagorean theorem. So remember, Pythagorean theorem says that if you take the two legs, which are A and B, so I'll do A is 18 and B is 24. So if you use these legs, right, and then you call the hypotenuse C, then you can do A squared plus B squared is equal to C squared. The two legs squared, add them together, equals the hypotenuse squared. Right, remember, C is always the hypotenuse. So I'm going to make a note of that. C is the hypotenuse. Okay. All right. So now we can plug in our values and we can solve. So A squared is going to be 18 squared plus B squared, which is 24 squared, equals C squared, which is our D squared for diameter. Square them. I'm using the calculator. So 18 times 18 is 324 plus 24 squared. So 24 squared, 576. That equals to D squared. If you add those up, you get, so I'm doing it in the calculator, you're going to get 900. So 900 is equal to D squared. And then hopefully you recall that in order to get rid of the squared, you have to do inverse, which is square root both sides. So in the calculator, I'm square rooting 900, and I'm getting 30. Okay, 30 times 30 is 900. So my diameter is 30 here. Okay, but remember, to plug into our circumference, we need the radius. To plug into circumference, we need the radius. So we're going to find the radius by doing diameter divided by 2, and we're going to get 15. Okay? Last but not least, we find our circumference, 2 pi r, plugging in our radius of 15. And so it says in terms of pi, that means pi better be in the answer. Okay? Pi is this, right? That's pi. So we need pi in our answer. So all we have to do is 2 times 15. Okay? So our circumference here is going to be 30 pi. Okay? It's going to be 30 pi. All right, so there is the answer for that one. And there's no units to do on this one. So just recall, because this one's kind of tricky. Whenever you have a rectangle or a square, okay, any length, width, and it's inscribed in a circle, you can always use the fact that those right angles, okay, make it so that if I draw in this diagonal, it's going to be the diameter, okay? That's very, very important that you understand that that will always be the diameter. In that case, you can use the Pythagorean theorem every time, whether it's a square or a rectangle. You can use the Pythagorean theorem to find that value, okay? And if you're lucky, it'll come out to a nice number like we got here. Once you find the value of diameter, just divide it by 2 to get the radius, and then you just plug that into your circumference formula. Or, honestly, if it's asking for area, same thing. Use a different formula, but you still just plug in. All right, perfect. Example 4. So in the figure shown, the two circles are tangent, where the inside circle passes through the center of the outside circle. The diameter of the larger circle is 20 yards. What is the area of the shaded region in terms of pi? So in the figure shown, the two circles are tangent. That means that one circle touches the other circle. It doesn't cross over the other circle. And so hopefully you can see that where they are tangent is this point right here where they touch. Okay? It says that the two circles are tangent. The inside circle passes through the center of the outside circle. So the inside circle passes through the center of the outside circle. And it's asking for the area of the shaded region. So it's asking for the area of part of a circle. So this shaded part here is part of the bigger circle, right? It's whatever the bigger circle would have, right? Whatever area it would have, minus this white part here. Okay, minus this white part here. So it's kind of like that problem that we did with the wooden picture frame, right? If you find the area of the big circle, you can subtract the area of the small circle. So what we're trying to do is area of, I guess I'll do it this way, outside minus area of inside. That's what we need to figure out, okay? Area of outside minus area of inside. So, okay, so let's look at this. So it says that the inside circle passes through the center of the outside circle. That means that that inside circle passes through the center of the outside circle. So if I draw in the diameter of the smaller circle, basically this point where that diameter ends, so this point here, this point here is going to be the center of the outside circle. So this is the center of the outside circle. Okay, that's what that point is. So that means that this whole distance right here is actually the radius of the outside circle. Okay, it's the radius of the big one, just like it is on this side, right? I guess I can draw it on that side. So that's the radius of the outside circle. What it gave us was the diameter, of the larger circle is 20 yards. Okay, so this diameter is 20 yards, which means its radius is half of that. Its radius is 10 yards, right? So that distance is 10 yards right there. Okay, that radius is 10 yards. So then if I want the radius of the smaller circle, because remember, you can only find area if you have radius. So maybe we should write that down real quick. So the area formula is pi r squared, right? Pi r squared. We have to find the radius. Well, we have the radius of the big one. This is the radius of the outside. Now we need the radius of the inside circle. Okay, now we need the radius of the inside circle. So that means it's going to be half whatever this is. Well, that's the same as the other side. So those are both 10. Okay, so let's make a note of that. So those are both 10. So to find the radius of this one, to find just halfway across, it's going to be 5. It's going to be half of 10. Okay. So again, if that whole diameter of that larger circle is 20, then half of it is going to be 10. So there's going to be 10 on the right and 10 on the left. And then the radius of the smaller one is going to be half of that, which is going to be 5. So the radius is 10 yards of the outside, and the radius is 5 yards of the inside circle. So now we have to use both of those radii in order to figure out the area so we can subtract them, okay? So we're going to be doing pi r squared minus pi r squared, but the r's are going to be different. So for the outside circle, our r is 10 yards, so this will be pi times 10 squared minus pi times the radius of the inside circle, which is going to be 5. So 5 squared. Now it wants it in terms of pi. So that means that we can go ahead and not multiply by pi. Only square the radii. So 10 times 10 is 100. So this one's going to be 100 pi minus 5 times 5, which is 25. So that's 25 pi. And then you can basically treat it like terms. You can just subtract the numbers and then keep the pi. Okay, so 100 minus 25 is 75 pi. And since it is yards, it would be yards squared because it is area. Yards squared because it is area. And that is the area. I'll just write it like this, is the area of the shaded region. Okay, it's not the area of one circle or the other. It's the area of the shaded region. It's the area of the outside circle, which is the bigger one. So that's the pi 10 squared, minus the area of the inside circle, which is the smaller one, which is pi 5 squared. Okay, and when you simplify it out, you get 75 pi. Now, if it wanted the answer rounded, simple. You just multiply these together, 75 times pi, and then you round it. Okay? All right. Let's go ahead and go to example 5. It says a circle is inscribed in a square as shown in the diagram below. The diameter of the circle is 11 inches. What is the area of the shaded region rounded to the nearest hundredth? Okay, so thinking about the question of, okay, what value are you looking for, right? It gives you a circle, it gives you a square, it gives you some information, but it wants to know the area of the shaded region. So it's looking for area again. This is actually a very common question, looking for an area of just a portion of a figure, okay, of a shaded region, if you will. So this area is going to be, let's take a look. It's going to be the area of the square, but taking away all of the circle, right? So ignoring all of this circle and only leaving what's left here in these little sections here, these shaded sections. So it's the area of the square minus the area of the circle, okay, taking all that out. So what we're looking for is area of square minus area of circle. That's what we're looking for. Okay, and then it does give us some information. So let's take a look at that information. Okay, so the information that it gives us is that the diameter of the circle is 11 inches. So the diameter of the circle is 11 inches. Now, because it's inscribed, right, think about what I said on the other problem where it was inscribed, which is this one here. Yeah, example 3. Okay, that circle is not going to go outside of the square. It's just barely going to touch it. It's going to be what's called tangent, which we saw in the other problem as well. Here, 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 and here in 4 spots. And so that diameter is going to go across, sideways, or you go up and down, whichever, doesn't really matter. Okay, and that's going to be the diameter, but that's also going to be the length of one side of that square. Okay, and it's important that you see that relationship there, okay? So if the diameter is 11 inches, where did I get 15? Okay, so if that diameter is 11 inches, then the square also has a side of 11 inches. And so that means both, or all 4 sides of the square are 11 inches, right? There's 11 here, 11 on the top, 11 on the side, okay? And so it's going to be very easy for us to find the area of each now. Area of a square is just length times width. So that's going to be 11 times 11. So that's going to be 121 inches squared. Okay. It's just length times width. The area of the circle, of course, a little different. So you have to do minus pi times radius squared. Well, we don't have the radius. We have the diameter. So the radius is half of the diameter. It's 11 divided by 2, which is 5.5. Okay. So I'll plug that in, 5.5 squared. Now, notice that the answer doesn't say in terms of pi, it says rounded. So we can multiply by pi here. So it's going to be 121 inches squared minus, and I'm just going to multiply that all in the calculator. So actually, let me go ahead and show you how I'm going to do this. Okay, so how I'm going to do this is I'm just going to do, it's pi times 5.5 squared. So I'm going to do second and then get my pi button, right, times, and then parentheses 5.5 squared. Yeah. Okay, and that's going to be 95.03, rounding to the nearest hundredth, which I believe is what the problem said. 95.03. 95.03. Inches squared as well. It's going to have the same units because it's also an area. And then we just subtract. So 121, I'm just going to do this in the calculator, minus 95.03 is going to be 25.97. So the area of the shaded region is 25.97 inches squared, which again, I just got by subtracting the area of the square, 121 inches squared, minus the area of the circle. And of course, we had the diameter of the circle, so we had to divide by 2 first to find the radius to plug it in. And there we go. All right, last but not least. Oh, wait, that's it. I thought there was one more. Okay, cool. So that's it for those notes. Thanks for watching, everybody. Have a great day.